Imagine standing on a planet where rain falls as liquid metal, a world so close to its star that rock evaporates, oceans glow, and the surface reshapes itself every single day. This is not science fiction. This planet exists. Astronomers have seen it, measured it, and struggled to explain how anything at all can survive there. Tonight, we're traveling beyond our solar system to a place where iron melts, where lava flows like water, and where the laws of familiar geology completely break down. This is the story of planet so hot, it melts metal. And by the end of this video, you may never look at Earth the same way again. Before we leave Earth behind, take a moment to subscribe, because every week we explore real cosmic worlds that sound impossible, yet are proven by science. In the early 2000s, astronomers were hunting for something simple. Not alien life, not Earth-like planets. They were searching for patterns, tiny wobbles in distant stars, that might hint at unseen worlds orbiting them. That's when one star, located about 640 light-years from Earth, began behaving strangely, dimmed, brightened, and shifted in ways that didn't quite make sense. After months of careful observation, scientists realized something extraordinary. A massive planet was orbiting this star, once every less than one Earth day. That planet would later be named KELT 9b. At first, astronomers thought it was a mistake. Planets aren't supposed to orbit that close. They're not supposed to survive that kind of heat. And yet, there it was, very real, very massive, and unbelievably hot. KELT 9b is what astronomers call an ultra-hot Jupiter. It's a gas giant, larger than Jupiter, but instead of orbiting far from its star, it clings dangerously close. So close that 1 year on KELT 9b lasts only 36 hours. To put that into perspective, if Earth orbited the Sun at that distance, our oceans would boil away in minutes, our atmosphere would be stripped into space, and the planet itself would slowly begin to unravel. Yet KELT 9b remains, barely holding itself together, in a cosmic balancing act. Here's where the story turns extreme. The dayside temperature of KELT 9b reaches over 7,800 degrees Fahrenheit. Hotter than many stars. That's hotter than lava, molten iron, the surface of Mercury, even some red dwarf stars. At these temperatures, molecules don't just break apart. Atoms themselves are torn open. Hydrogen turns into plasma. Iron vaporizes into gas. Titanium and silicon exist as glowing atmospheric clouds. This isn't weather as we know it. This is planetary disintegration in real time. One of the most shocking discoveries about KELT 9b is what happens in its atmosphere. Astronomers detected vaporized iron, magnesium, calcium, and titanium floating above the planet. On Earth, these materials form mountains. On KELT 9b, they float like mist. As the planet rotates, its night side cools slightly, just enough for these metals to condense. And when they do, they fall. As metal rain, iron clouds collapse into droplets. Magnesium vapor condenses into molten beads. And those droplets fall back toward the planet, only to evaporate again as they reach the scorching daylight side. A never-ending cycle of metal storms, wrapping around an alien world. KELT 9b's star is not gentle. It's nearly twice as hot as our sun, and emits intense ultraviolet radiation. That radiation is so powerful, it actively tears the planet's atmosphere away. Scientists estimate that KELT 9b is losing thousands of tons of gas every second. In cosmic terms, we're watching a planet die, slowly, violently, inevitably. Here's the mystery that keeps scientists awake at night. KELT 9b should not be there. Most gas giants form far from their stars, where cooler temperatures allow gas to accumulate. So how did this planet end up in a place that actively destroys it? The leading theory is planetary migration. KELT 9b likely formed far away, then slowly spiraled inward over millions of years, pulled by gravitational interactions with other planets or its star. By the time it reached its current orbit, it was already doomed. We are witnessing the final chapters of its existence. At first glance, KELT 9b feels distant and irrelevant, but it tells us something profound. It reminds us how fragile habitability really is. Earth exists in a narrow, delicate zone, where temperatures allow water to remain liquid, atmospheres remain stable, and chemistry can slowly build complexity. Move just a little closer to the sun, and Earth becomes Venus. Move a little farther away, and it becomes Mars. KELT 9b shows us what happens when a planet crosses that line entirely. With telescopes like the James Webb Space Telescope, scientists are now studying planets like KELT 9b. In unprecedented detail, we can analyze their atmospheres, measure their winds, track their evaporation, and each discovery reshapes our understanding of how planets form, evolve, and die. These extreme worlds help us better understand our own. Eventually, KELT 9b will lose too much mass to survive. Its atmosphere will thin, its gravity will weaken, and the star it orbits will finish the job. What remains may be a scorched planetary core, or nothing at all, a reminder written in starlight that the universe is not designed for comfort. It is designed for change. Somewhere in the Milky Way, a planet rains molten iron, not because it's cursed, but because physics allows it. And if a world like that can exist, then the universe is far more diverse, far more extreme, and far more beautiful than we ever imagined. If you enjoyed this journey, leave a comment below. Would you survive even 1 second on KELT 9b? And subscribe for more true cosmic stories that sound impossible until science proves them real. Soft pause. The universe has many secrets left, and we've only just begun to uncover them.